Hey guys, welcome back. So far we did the power rule, the product rule, the quotient rule, and now we have one more rule. It's called the chain rule. So the chain rule can be really tricky. So I'm going to first show you how to identify the chain rule in a problem. So first, I have this function x squared times sine x, and if I was going to ask you to take the derivative, you would have to use the product rule. The reason why we would use the product rule in this case is because I see an x times an x. In the next example, it looks like a quotient. And it will be a quotient because I have an x and an x. But remind yourself, just because it has this line here showing that it's a fraction doesn't always mean that it's going to be a quotient. It's a quotient because there's an x in the numerator and there's an x in the denominator. It's a product because there's an x times an x, okay? Now, everything else is going to be a quotient rule after the, other than these two examples. Okay, so why is the third one a chain rule? This guy right here is going to be a chain rule because you have some sort of base to a power other than 1. If you have a base to a power other than 1, then you're going to have to use the chain rule if they ask you to take the derivative. Same in the next example. You have a base to a power other than 1. You have a base to a power other than 1. Okay, anything other than 1. Now, these guys are also chain rule. So right now, in these examples, I showed you where we have basically like a polynomial raised to a power. That power just has to be other than 1, and that will tell you to use the chain rule. In these examples, they are all about the trig, and the reason why I know it's a chain rule is because their angle is other than 1. So if your angle is other than 1, you have to use the chain rule. Now, also for trig, if their exponent is other than 1, you have to use the chain rule. So if your exponent is other than 1 or your angle is other than 1, you must use the chain rule. In this video, I'm only going to show you guys the ones with the polynomial raised to a power, and then in the next video I'll start making the problems more challenging. So how do we use the chain rule here? In this example, I want us to find the derivative, so I'm going to start with f prime of x. The way we do that is we take this power just like a power rule and we multiply it with the coefficient in the front, which is in this case 1. Then you recopy inside the parentheses just the way it is, and you reduce this exponent by 1, just like the power rule. Now there's only one extension. You multiply by the derivative, let me get a different color. You multiply by the derivative of the inside, which is 2x plus 4. Now you're basically done with the chain rule. You're going to do 3 times 2x plus 4, and that is basically the only math or algebra that you're going to have to do for this problem. Okay, so you leave your answer just like that. So once again, you take the exponent, you multiply by the coefficient, you recopy the inside, drop this by 1, and then times the derivative of the inside. Let's try another example. This is a chain rule. Why? Because I have an inside raised to a power other than 1. Okay, so let's do this. 8 times 2. First of all, let me show you that it's f prime of x. 8 times 2, 16. Recopy the inside, drop the exponent by 1, times, always times the derivative of the inside. The derivative of 4x is 4, and the derivative of sine x is cosine x. And then you could just leave it like that, and you're basically done. That's the derivative. So that's us using the chain rule. Let's try another example. This example here, why am I going to use the chain rule when I find the derivative? Because it's a base to a power other than 1. So I'm going to take this, times it by the number in the front, just like a power rule. Half of 6 is 3. Recopy the inside. Reduce the exponent by 1. So this 6 becomes a 5. And then times it by the derivative of the inside. The derivative of 3x squared is 6x to the first. The derivative of tangent, I hope you guys remember, it's powerful, so it has a power. Tangent always goes with secant, so it's secant power, so it's secant squared x. And then you just leave it like that. And that's how you do the chain rule. In this problem here, and this is the last problem in this video, I'm also going to use the chain rule. Some of you might say, oh, it looks like a quotient. It's not a quotient rule because there's no x in the numerator. You must have an x in the numerator and denominator in order for us to use the quotient rule. You could use the quotient rule if you wanted to, but it just takes longer. So what I'm going to do is I'm going to say 1, 2x plus 3 to the negative 4. So I rewrote that. Okay, I rewrote it as a negative 4. Now what I'm going to do in this case is I'm going to do the chain rule. If you guys remember why, it's because my exponent is something other than 1. Negative 4 times 1 is negative 4. Recopy the inside, drop it by 1, becomes negative 5, times the derivative of the inside, which is just 2. So the way you clean it up is you say this is going to be negative 8 times 2x plus 3 to the negative 5th, which can also be negative 8 over 2x plus 3 to the 5th, since the negative exponent only belongs to this guy. So come back for more challenging problems, which are really not challenging. It's the same exact rule. But come back and see some more examples that involve trig.